In this video, I will go over the final test case that will motivate the code for the solution to the alien language leet code problem. When we set up initially with W and T, what we're going to have is we're going to have vertex. I'm going to put the data value, and then outgoing edges, and then I'm going to have the parent. So it's 0. When we insert it, the data in that structure is W, and right now the outgoing edge is going to go to vertex 1. Its parent is going to be -1, so there's our sentinel. This second vertex, vertex 1, is going to contain the data T, and as of right now it's not going to have any outgoing edges, and its parent is 0. At the algorithmic level, the graph looks like this. So now we're going to start inserting these characters. At vertex, this third vertex, which is vertex 2, we're going to insert the data value E, and as of right now, it also doesn't have any outgoing edges, and its parent is going to be 0 as well, because W and E is the current ordering. When we insert the next value, which is R and F, R is not contained, and as of now, it doesn't have any outgoing edges. 3 now has vertex 2 now has an outgoing edge to vertex 3. And 3's parent is 2. At the algorithmic level, it looks like this. That should be R. Now we're going to insert F. So at F, we are now going to have no outgoing edge. Its parent is 3, and that means we have an edge from 3 to 4 for R and F. So the outgoing edge here is going to be 4. We're now going to see a pattern until we get to this last letter T between I and T. So what we're going to see here is vertex 5 is going to contain the value G. This is going to have an edge from 4 to 5, and this one's parent is 4. Same thing at vertex 6. Vertex 6 is going to be the letter H. It's going to be 5 to 6, and its parent is 5. Here we're now going to have vertex 7, which is going to have the letter 8. So did I miss everything? G, F, G, H, A. Okay, this will be 6 to 7. This parent is 6. Vertex 8 is going to contain the data B. There's going to be an edge from 7 to 8, and 8's parent is 7. And then we get to 9, and 9 has the data I. There's an edge from 8 to 9, and 9's parent is 8. And at the algorithmic level, we have W, E, R, F, G, H, A, B, and then I. So this is the graph up to this point. So now we have to evaluate what's going on here between I and T. We check to see if T is in the graph, and we see that it is. And right now its parent is W, and it has no outgoing edge. So what we need to do is we need to run a depth-first search between the current parent and the value we're updating. Does there exist a path between 0 and 9? In this case, we go from 0 to 1. And I realized that one thing I should have done here is put a 2 there. So now we have a representation of these edges. So we go from 0 to 2, 2 to 3, 3 to 4, and all the way to 9. And we see that there exists a path, which means we know that there is a path here and that there should be a path here. So if this exists, we now have our 3-node problem. We can update this by removing the edge from W and T. So we get rid of this. And now the outgoing edge goes appropriately to E. Then we look at 9 and say, well, we need an outgoing edge to the currently existing location, which is vertex 1. Once we do that, now we have our proper ordering and our final alphabet.